Once again, switching back to English. I think I said that already 10 times today, but there's still one to come. It's very nice to see still so many people here attending this event. Now we are talking about ports, marine, this kind of usages which are fast-growing usages because it basically started about 2 or 3 years ago. We started to see a lot of projects relating to marine, but also the ecosystems on the port. And to talk about that, I'm very happy to have Cédric Rouault with us, who is from Ricardo. Ricardo is a very famous consulting company, but I'll leave it to you to present what Ricardo is about and what you're doing there. Please.
Thank you very much, Bertrand, for your time and having me here. I'm replacing Joanna Richard, our head of hydrogen business, but I'm head of fuel cell systems, so at least I'm in the business of hydrogen and fuel cell. And yes, I'm in Ricardo now since 13 years, working on thermal management systems and in the recent years on the fuel cell systems. So we develop fuel cell systems and the integration of fuel cells onto different land, sea and aerospace applications. And we will talk about sea, which is very close to my heart because I'm a sailor.
You're a sailor, great. So you're very interested in the subject. And by the way, I've been told that Ricardo has been working on the definition of the ecosystems, the port. Am I right, or?
That's correct, yes. We are helping with our energy environment division, the development of the ecosystems around ports, airports as well, but today we speak about port. And it's not only the hydrogen economy, but it's to go to net zero. So that means that we have also pure battery electric vehicles, ships in the port, and we deal with all the energy storage that is required or the energy produced. We just heard before us about the production from some wind farms in the sea. So how much energy do we need to provide to the different vehicles that are in the port, the cranes, the excavators, the trucks, the buses, to move people, but also to refuel the ships that are coming to the port. So all this, we can see that if we don't have a modeling approach, we can very quickly see that we don't have enough energy. So that means that some ports, even if they have enough land close to them, or all the amount of the sea to install solar wind farms, and on the land solar farms, they don't have enough energy maybe for all replacement of the diesel, the fuel, the kerosene that they need to have for the all operation of a port.
Okay, well, first of all, we need to understand why this is happening, because, well, my personal understanding is that the International Maritime Organization has put some very, very strong objectives in terms of decarbonization, and that when you think about a boat that will be on the seas at some point, and the lifetime of these boats, this means that they need to work on that right now. Am I right on that?
Yes, so the IMO has set the target of minus 50% of CO2 emissions for 2050. The status is that the ships are already very efficient. The large engines, and Ricardo, we have developed a lot of large engines in the last 100 years because it's our business. So Ricardo has created a business 100 years ago around engines. And we continue to develop those engines, diesel engines, natural gas engines, and also now hydrogen and ammonia engines. But those engines using diesel, they're already at 45% efficient, 50% efficient. So they are more efficient than the cars that we are having, even in a hybrid vehicle nowadays, except maybe with
because
Toyota.
they are bigger.
They are bigger, they run slower, they control better the combustion, they operate on a fixed operating conditions and not doing transient all the time. And that means that they are at the moment only representing 2.5% of the CO2 emissions globally. But because the other sectors are reducing their CO2 emissions, they need to do something. They cannot wait.
Yeah. And of course, the boats, they need to fuel somewhere. They land to a port. So what does it look like a hydrogen port ecosystem? How can we define that?
So ideally, to go net zero, we will have to have a green hydrogen production center, so with electrolyzers, using wind farms, solar farms, that will be close to the port. The whole ecosystem will also need to have organization of the distribution, not only the production, but distribution of the hydrogen around the port. So that means shipping, not shipping, but moving the hydrogen tank storages through trucks or pipelines, because a port is quite a large area, and also to be connected to the rest of the country, I would say, not just work in isolation. All this needs digital modeling. So this is what we try to promote by having models to understand the needs for all the vehicles, the ships, when they come. They need to have the capacity to refuel right away. They don't want to wait. When they wait, they need to also operate in zero emission. So that means that they can use fuel cell systems, even if they have still got diesel engines on board, like cruise ships for tourism. They will come to the port and they will do zero emission by doing that. And they need to refuel in a quickly manner, in a safe manner. So all this needs to be taken into account in the ecosystem. So this is why consultants like me are helping to develop the models to understand the needs, the requirements, and how to implement that in a safe way.
If we look at the different directions for various ship projects, we see many types of vectors being used potentially. Ammonia, methanol, hydrogen, whatever, gaseous or liquid, right? And all those things, we will need them at the same time on the port.
That will be a challenge, of course, but there will be a phase of transition. We're not saying everything will be hydrogen. First, there will be also pure electric systems operating. There will be vessels that don't need to have hydrogen because they don't have a big requirement in terms of range, autonomy. When they move inside the port, they can just recharge when they are not operating. The same for some vehicles. But for the ones that are coming from a long way, that are staying and need high power for hotel loads, they will need to be zero emission, so they will need to operate with the fuel cell. But coming back to your question with the different vectors, we don't see one solution that fits all, of course, as usual. But there will be bioethanol, there will be CNG, LNG, ammonia, and hydrogen. But we see a trend with hydrogen and ammonia being the ones that will remain in 30 years' time, because we are on a long cycle. So that means that we will not change everything in just a year or two. It will take time, and that we know those cycles is really around 30 years. We see ships that are still operating very well at 30 years. So there will be retrofit, there will be conversion, and we support also this type of activities, not only for the ships, but also for the vehicles that are in the ports. Some vehicles are only used 4 hours per day and every day, but that's not enough to say that after 5 years they are dead. So they should be used, and if we want to remove the diesel powertrain from that vehicle, we can do that, and we can put a retrofit kit with a fuel cell, with a battery, for them to be able to be zero emission on site.
But remind me, if I'm not wrong, if I want to produce ammonia, I need hydrogen, right?
Yes.
So how are we basically saying that a port should be potentially a big production site that would maybe convert part of this production to produce methanol, to produce syngas, to produce ammonia or whatever, which means that the port will become a big industrial production site?
So for that, the ports are looking for help to understand their strategy, because having all the fuels on port so far, and I'm on the technical side, I don't see that happening. It will be too complex. So they will need to choose some vectors. Other, by history, will continue with what they have, will evolve slightly. Others will do a big gap, and they will jump, for example, to hydrogen or ammonia. But because they know also their clients who will come to the port, what powertrain they will use, they know which vehicles they have on port and how they can convert them with the cheapest solution for them to reach the net zero, because it's always a question of money. Of course, you cannot replace by new buses, new fuel cell buses, new vessels using liquid hydrogen without a lot of money. So that will take time. They need help from local government, from Europe or US or China government. And for that would help them to drive their strategy. But it's really a question of defining the strategy properly.
You raise a good point because a port is a multimodal hub. There are trains arriving there, trucks. Very often there is a city, so there are other types of vehicles for transporting people or goods. And there are ships and whatever. And sometimes there is a river or a canal, whatever. And we need to consider all that together. Where do you see today, notably in Europe, interesting examples or projects of first stages of deployment of such ecosystem?
I will start with the country I'm living in now, which is in the UK, although I'm French.
Okay.
But I'm in the UK since 13 years.
Nobody's perfect.
Yes, thank you. The thing is, we have two examples now. We have Orkney Island, which is the north of Scotland. It's a nice place above the place where you can find nice whiskies. And also the Shetland Island, which is a bit more remote, close to in the North Sea. And those two will have an ecosystem at least modeled through UK government funding projects that have started in September this year. And we will see the conclusion about their strategy for the Shetland Island and for Orkney Island in terms of what will be the net zero strategy involving hydrogen economy. And that means that they will have the model from Ricardo in terms of the vessels, if they will use different powertrains, engines and fuel cells. Different types of fuel cells also, depending on the different fuels, and what could be the best solution. So that means we need to run a design of experiment, we call that. So a lot of scenarios, and we need to choose the ones that will give the best result for the lowest cost for the local economy. So of course, Scotland has got big amount of money through what they do at the moment with the production of petrol, but they have to move into that to go to the net zero.
Do you see other places in Europe where this is happening?
So the largest harbor, of course, you have Rotterdam, you have Barcelona. So we have done projects in Europe. I cannot name all of them because I don't know all of them by heart, and some are confidential, but where we have helped them to develop the strategy in Europe. You have the same, I can name that, in Los Angeles. So we have helped, for example, Toyota, and it's public domain, to convert their trucks in the Los Angeles harbor with a fleet since 2016 now, and we are continuing, because they want to be net zero before 2030 for at least the fleet of trucks that are in the Los Angeles area. So California is the one that we are looking for, is the benchmark, and this ecosystem and model will begin to be applied as usual, moving from California to the rest of the world, actually.
My feeling is that it is finally it's much easier to implement those new propulsion system in a boat because you have a lot of place, because the constraints are less problematic than on smaller vehicles, and that finally the real difficulty is in the infrastructure itself, on the ports, because they have not been designed necessarily to host this kind of new equipment. So how are they going to deal with that?
If we speak a bit with some figures for the large vessels usually they use up to 30 megawatt of installation to move very quickly from one port to another. That is for cruise ships, for example. When they come to the port, they need multiple megawatt, between 2 and 5 megawatt, just to generate electricity, hot water as well, for the operation of the port for at least a day before they move on the night after. They will need to refuel at the same time there when they operate under, for example, hydrogen fuel cell, PEM fuel cell. When they do that, they need to do that quickly and safely. So that means that we need to have potentially multiple tanks on the vessel to be able to be refilled at the same time, and not just one big lump of pipe of hydrogen that will come to the ship, because you will have too much leakages, so loss of hydrogen with the risk of safety. So all this is being designed in terms of container of tanks for the vessel itself, and in synergy with the infrastructure that we need to be put in place. So when you have to, if you store hydrogen on the ship under 700 bar or 350 bar, you will need to be able to recharge at 400 bar, for example. If it is liquid hydrogen, you need to be able to have that capability to have liquefied hydrogen in the port and transfer that in a safely manner also to the vessel. So they need to invest also into all this, and that's a big capex for them that they will have to find a return on investment very quickly, and not in 30 years.
Yeah, there is a business model issue to tackle. Another way I can see this deployment would be producing renewable energy offshore, converting that to hydrogen, going directly into pipes. The pipes goes to the port, and then we have a liquefier in the end on the port that is going to put the energy in the boat. Is this stupid to think about that, or?
No, not at all. It's the idea really, when we think about green hydrogen, we know we will not move into green hydrogen in just a year or two. So this is why people talk about the blue hydrogen. And this is the most of the production nowadays, gray and blue hydrogen. So this is why there's debate, but it's not the purpose of this meeting today. But the thing is, the idea is really to have that the wind farms generating the electricity for the electrolyzers. And the wind farms example, if you just take a look on the map, so I'm coming from close to Brighton, South London. In front of Shoreham by Sea Port, there is 200 wind farms, wind farms, sorry. And that is without having the hydrogen economy already in place. It was just because it's an area where it makes sense to generate electricity from the wind. And I can tell you because I'm a sailor and it's very windy over there. So the thing is, it's the idea is an ideal idea to go from the wind farms to the electrolyzers to generate liquefied hydrogen. But I see already customers that are coming to us with this idea that they will have the ship, they will have the place, and the packaging of a fuel cell and a liquid hydrogen tank is not that easy. The weight is not a problem really for a ship. The big problem is the packaging volume, because if it is a cruise ship, you want to have more rooms for people to enjoy their time on the ship than having a powertrain, actually. So you need to develop solutions that are quite compact, and it's not the same as what we have on land, actually.
Okay. And we talked about Europe, but do you have an oversight on what's going on in other countries like China, Australia, the US? We talked about Los Angeles, but are all the ports around the world thinking about it?
A lot of them have already come to consultants like Ricardo to develop their models and around the hydrogen economy, or the net zero economy, sorry, and hydrogen economy is one answer. And we see examples in South America, Chile, for example, Argentina. They want to do a lot, maybe because they want to do that jump, actually, to move quickly to the next step and not do just the Kaizen approach, the small step approach, just to go with a big step. China, I'm not the expert, so I will not be able to say that. Australia, they're a bit behind. They have just announced, the Australian government, their hydrogen economy with billions of Australian dollar at stake. But they are one of the latest, I would say, because Europe or US have already announced much before, 6 months ago, 1 year ago, 1 year and a half ago. Europe was one of the first to mention the billions of euros that will be invested globally, not just for the ports. But Australia is a latecomer, I'm afraid to say, if there are Australian people. But they will catch up. I'm sure they will.
Yeah, they will catch up because they have the potential to produce a lot and potentially a very big customer, which is Japan. Not so far. Which comes to the next idea. A port is also a place where you can fuel big ships to transport hydrogen and deliver to another port. Okay, we're talking about transportation of that energy, not only using it as a propulsion solution. And that's something, again, different. We see that in Australia. We see that also in other places. Have you been facing this kind of case?
It's under the discussions and the models that needs to be refined, of course, because if you ship the hydrogen, how do you move the boat if it is with a fuel cell or with a hydrogen engine, which is not ready yet. So at the moment we're still with a diesel or LNG or CNG engine. So that means that you're not yet there with the net zero economy. But if in the liquid hydrogen form, there are different examples led by Asia, so Japan, Australia, as you said, where they start to have those big tanks just for shipping the hydrogen from one country to another on a long distance also. We hear, of course, about pipelines between Saudi Arabia and Europe, Morocco or Algeria and Europe as well. So not just by ship, you can, but big pipelines is also the dream of some people, and the dream now is coming to be true.
But you cannot have pipes everywhere, okay? So many are thinking about why choosing the ammonia vector actually to transport that energy from one place to another one. So ultimately, the port is going to be an hydrogen country by itself. And do you see that happening within what, 15, 20, 30 years?
I hope I will be able to see it and we'll still be working. I'm not close to retirement, but I'm already a long way in the career. So the thing is, with what's happening in Los Angeles, for example, as I said, is an example because they have already started to really forbid emissions in their harbor, and that will be before 2030. So for that, that is only, for example, at the moment on the land because they don't have the ships. But I see that moving quite quickly for the land because converting the vehicles will not take 10 years. It can take the next 5 to 7 years, roughly. If you convert hundreds of vehicles per year, or tens or hundreds of vehicles per year, you will be able to convert your whole fleet to net zero. It could be pure battery electric vehicles, you will need recharging stations, but also hydrogen engines or hydrogen fuel cells that will be on board. They will not use ammonia, those vehicles, the cranes and so on, sure. but the ammonia will be potentially for the ship. So that will start with the land, which is easier. For the ships, we see strategy being developed, and the ones who have got CNG or bioethanol, they will continue. They might move to SOFC and not keep with engines. That's something maybe we have not seen so much in the conference these 2 days, but that happens in the rest of Europe or the US. And finally, I would say that it's how quickly you can install and demonstrate. For that, you need demonstrators, for demonstration to the rest of the world that you can replace on large ships the conventional powertrains, and that takes money. So that means that we will see demonstrators in the next 2 to 3 years. There will be a lot that will arrive because there's been plenty of announcements already last year during the COVID, the core of the COVID. But people have continued to work quite hard, and in Europe, through European funding government projects, we will have the possibility to have demonstrators in 25, 26, before going into production, certainly starting before 2030. So I will say that in the next 8 years, we will see already a big move to that hydrogen economy.
It's tomorrow.
It's tomorrow.
That's it. Yeah. Okay, man, that's a good conclusion. It's time to end this session. Thank you very much for being here and for all these informations about the port ecosystem. Thanks a lot.
Thank you, Bertrand. Thank you, everyone.